All right, so we can look at the displacements as we were just talking about. I'm sorry, let me go back to the primary. All right, so primary, we were looking at the stresses S11, and then we are looking at the stress S22, and S22 is the stress in the vertical direction. If you ever want to know what the direction of the stresses are, you can always use this tab, which will show you the direction. So this is the symbol plot. So when you use the symbol plot, it shows you the direction of the vector. So for example, U1 was the displacement in the one direction. Similarly, U2 was the displacement in the vertical direction. And if you wanted to look at the resultant, it would show you the resultant of the two displacements that are occurring at all the nodes as shown there. If you wanted to see what was the direction of S11, that's the direction of S11. It's in the horizontal direction. Now you can also switch off the, make the elements transparent like that using the key up there, or you can fill it up as shown there, or you can use a translucent option as shown here. It's up to you which way you like to look at the analysis results. S22 is in the vertical direction. There you go. That's the stress that I think you will be able to calculate on your own. And see, notice that it doesn't let me have an option for S12 because it doesn't know how to show the direction for S12. It's a shear stress. It's on both. It's in all four. It's in both the horizontal and vertical direction. So it doesn't want to show a vector for that. But it'll show me S11 and S12. While I'm at it, you will also notice that it will show me the max in-plane principle. That's the maximum in-plane stress direction. It won't give me the value, but it shows me the value of the maximum in-plane stress. That's what you're looking at over here. You can also look at the minimum in-plane principal stress. You can look at the direction in which those arrows are flowing, and you can look at their magnitude in the contour plot. And you can also look at all principal components at the same time. And this shows you both the maximum and the minimum in-plane stresses, the magnitudes and the directions obtained from the analysis results. Great, isn't it? But how am I going to know the numerical value of the stresses that I've just obtained? Am I going to read these contour plots, these small numbers over here? Probably not. In fact, these numbers are too small for us to even read. So what we're going to do is we're going to fix that. We're going to view port annotation options, and we'll switch over the font for all of them, particularly the legend, to something bigger, about 12. Let's see if it, there we go. The numbers have become a little bigger so we can read them. Of course, you could make it bigger. And I can also apply this to all of the triad, the legend, and so on. But I'm not going to worry about that right now. I'll click OK. I've made it a little bit bigger. And I don't want to see the bounding box for the legend. It's irritating, so I'm going to switch it off. OK, so now I can see my results. Now I can also move the model around using this pan tool, and I can also rotate it if I wanted to do that. Here you go. I'm rotating it now. I can also go back very easily to the XY plot as shown here using these keys. And I can also zoom in or zoom out using my magnifying tool. That's for zooming out. This is for zooming back in. Can also zoom into one specific portion of the model like that. And I can zoom back out. So those are some of the keys that I will end up using for this system. Now, in order to look at the stresses in particular elements, there are different ways to go about doing this. I can use the probe tool, which is once again back. This is the query information, or the I tool is back here. And now I can probe values, and I can probe values from, as you will see in a moment, as the box comes up.